Hey everyone, and welcome to episode 2 of the Beginner's Guide to Carveco. Now if you haven't seen part 1, link is in the corner. We started by creating our very first model, ran through the user interface to see where everything sits, and started doing some basic drawing and text work. Now in part 2, we are going to finish that project off, start to create some toolpaths for it, and ultimately get everything exported ready for our CNC machine. Now do remember, obviously you can skip through using the slider for the different chapters, or they will also be listed in the description area below. But let's jump back onto the PC and keep this tutorial going. So I've shown you how to draw some very basic shapes, and I've also shown you how to use the text tool. Now let's just create something very simple, such as a name plaque. For the time being, I'm going to leave this in place, but I'm just going to shrink it down slightly. So I'm going to hit the T, and I'm just going to use the anchors to shrink this down, and then I'm going to hit F9 to center it back in the middle. Next, I'm going to come over and use the rectangle tool, but I'm going to change it from square that we used earlier to the rectangle. And I'm going to draw a rectangle around this. We're just going to make a very simple name plaque. And let's round those corners off a little bit to save it being so harsh. We'll click Create. And again, I'll hit F9 just to make sure it is centered. So there is our basic name plaque. Now, if you are new to CNC and not familiar with terminology, this is typically known as the CAD phase, C-A-D. What we need to move on to next is the CAM phase, C-A-M. The difference basically being is the CAD is the drawing out of the shapes. The CAM is telling the software and ultimately the machine what we want doing with all those individual shapes. And that's what we're moving on to next. Essentially what we are going to do is use this outer shape to cut all the way through the material, and we're going to use the text to pocket it out, essentially so it just machines the entire middle of the name out. So I'll deselect everything for now. As I briefly touched on earlier, there are some shortcuts to the toolpath creation options up here, but also we can click on the toolpaths menu on the right hand side, and what we can see straight away is we've got a few more options. We've got 4 or 5 up here, whereas we have about 8 going on down here. I say 8 because the second one under 3D is actually for laser machining, which we will ignore. So just as a reminder, if you hover over each tool, it will give you a description of what it does. We have profile, fluting, area clearance, V-carve, bevel, hole drilling, and inlay. Now I am not going to make this any more complex than it needs to be for the first tutorial. So today we are going to be focusing on probably the 2 most common used toolpaths features, which is the profile cut and the area clearance cut, and I'll explain both of these as we go through. So the goal with this sign is we want the outer line to be cut out from the material to make it its own standalone plaque, and we want each letter to be machined out as a pocket, essentially so that it is lower than the surface. And we can potentially do something like fill it with resin, paint it black, and ultimately make it look like a plaque. So the first thing we're going to do is select the outer line. This is going to be our profile line, and we're going to come to the profile toolpath. Now once you select this tool, you are going to be presented with a whole range of options. And as I said towards the beginning of this video, do not be overwhelmed by what you see. You do not need everything all of the time, and actually a lot of settings you may never touch or adjust. So the first thing we can see is we have this profile option here, and if I expand this menu out, we have 3 different settings: along, inside, and outside. Now we also have this allowance option here, and I'm going to explain this as simply as I can. Now just like in Carveco, imagine the pink line is the vector that we have just drawn, and this circle here is the bit that we are using to machine it out. Now if we select the along option, it will align the center of the bit directly on top of the line that we are following, and it will do that all around the profile of the shape. Now outside and inside are essentially the same but on opposite sides, so let's stick with outside for now. When using the outside option, it will factor in the diameter of the bit you're using. For ease, let's say the diameter of this bit is 6 millimeters. Therefore, it will offset this by 3 millimeters. So the outside of the bit basically is touching the line that it needs to cut. And that is essentially the same on the inside as well. It will bring the cutting line in to allow for the diameter of the bit again, so that it is touching the inside of the line. And I also mentioned that allowance option. Now the allowance only applies to inside or outside, and it is about offsetting the actual line itself. So we just said the bit is 6mm in diameter, and therefore the actual path it will follow will be 3mm away from the drawing we have done. Now we can use the allowance to bring this in or out if we want to give ourselves a little bit of a gap. Let's say, for example, we are fitting two parts together. If we cut one exactly on the outside and we cut one exactly on the inside, the two parts would be extremely tight being pushed together. To simplify this more, imagine a child's shape sorter. Now to cut the holes out, we would be selecting the inside path, and that would, as I say, machine the gaps out that we need. To cut the bits out of the material that go through it, we would select the outside option. And that would ultimately give us the male and female parts. But as I just explained, if we did them to the exact same offsets without any allowance, the shapes would be extremely tight going through each other. So this is where we could add an allowance so that one fits in easier than the other. For example, we might add an allowance of 0.5 mm just to ensure there's a bit of wiggle room when these two parts slide through each other. Or another example of how to think of it if you are used to power tools, if you draw a line on a piece of wood and about to cut it with your saw, it is essentially whether you're cutting to the outside of the pencil mark, the inside of the pencil mark, or directly on top of the pencil mark. The selected vectors menu is just an alternative way of choosing things. You can either select items individually, as we have done with the mouse, or if you have a more complex drawing, you may wish to select all the vectors on one particular layer, something like that. Most of the time you will just use the selected vectors option. Now the next two settings are ultimately about giving you nicer finishes when you are doing a job. First we'll start with final pass thickness. Imagine you're about to machine through 10mm wood at 1mm at a time. Now each pass it would go down 1mm, and the last pass would ultimately also be 1mm. But maybe you want to do just a slightly finer pass to guarantee that final cut is a little bit smoother. That is where this setting comes in. So you could do a super thin pass on your last one just to guarantee, as I say, that final cut is as nice as it can possibly be. And it is a similar thing with the final pass allowance, except while the thickness is about the vertical movement of the bit and controlling the depth of that last pass, the final pass allowance is essentially about the left or right movement of the bit. If you have machined through anything before, you will know that each time the CNC router does a pass through the material, it almost leaves steps every layer that it goes down. And if you want to try and eliminate those steps within the material, you can use this final pass allowance. And essentially, whatever setting it is, it will bring the bit in just that little bit extra, essentially to almost take a shaving off the entire path that it has followed. Just as a quick warning to those with smaller machines, if you try and use this final pass allowance through deeper material and your machine is not capable of doing it, you run the risk of potentially ruining it. So whilst this is great for getting cleaner results, I would suggest testing with it first to make sure your machine is capable of doing it and that you don't do too deep of a pass with it. Next up we have cutting depth. Now at start depth, when you are beginning, most of the time it will always be 0. And this essentially just means that you're going to start from the top of your material. Just to give you an example of where this may be different, imagine if you're doing something like a coin catch tray and you want to engrave a name at the bottom of that. Now when you are machining the middle of it out, that will start at the top of the material, but when you come to engrave the name on the bottom, you will do that to the depth of where it has been machined out. So let's say if that bowl was 20mm deep, then the start depth for engraving the name would begin at 20mm deep. But as I say, for most of your beginners projects, it is going to start at 0. Now finish depth, obviously this will vary depending on how deep you want to cut through your material. The material we're using today is 18mm pine, and I want this to cut all the way through the material itself, so I actually want the finishing depth to be about 18.2. Now when it comes to the tolerance, the easiest way to explain this is basically how accurate the toolpaths are going to follow the design that you have done. The The best piece of advice I can simply give here is leave it at the default value. Mine in millimeters is 0.025 and I think in inches it is something like 0.01. I have never needed to adjust this tolerance in any jobs that I have done. Now I'll drag this down slightly, and next up we have the profiling tool, essentially the bit you are going to use to do all of the work of this particular toolpath. So we begin where it says click to select, and this will open up your tool database. Now I'm just going to minimize these down for the time being. Even though I installed this as a fresh copy of Carveco, it still remembered that I'd used some tool databases before, such as the SaintSmart, Amana and SpeedTool database. Now a tool database is essentially a core collection of bits that manufacturer may make, including things such as obviously the diameter of the bits, the speeds and feeds they also recommend. Most of the top manufacturers will have these available from their website, and you simply need to go and download them. I will put links in the description area to the ones that I have, such as SaintSmart, Amana and SpeedTool, so you can download them. Now just as a word of warning, I mentioned that these come preloaded with some speeds and feeds settings. These are basically the maximum that particular bit can cut to, not necessarily what your machine is capable of doing. You may have a more powerful machine that can go faster. Equally, you may have a smaller machine that has to go slower. So what I would say is don't necessarily rely on these speeds and feeds. Use your own judgment. And if in any doubt, always start slow, start shallow and then build up. So to cut this piece out, I'm going to use a fairly standard 1/8 end mill that you often get with some of the smaller machines. So I'm going to come to the SaintSmart menu. I'm going to select the end mill menu, and we can see these are in metric. Some will display in metric, some will display in imperial. Now a 1/8 bit is a 3.175 mil bit, so I'm going to select that. Now we'll see over on the right hand side it is displaying a list of speeds and feeds. Now one thing to remember at this point, if you edit any of these settings in here, you are editing the core information of this tool database. So for example, if we went into edit and we wanted to change the step down to, let's say, something like 0.4 millimeters and clicked OK. Now every time we load this tool in for a job, it will load it in at a default rate of 0.4 millimeters for the step down. But instead of always editing the speeds in the core database, we can change the speeds and feeds to vary for each particular job we are doing. So we've selected the bit we want. We're going to now click select. And as you can see, it has now switched to a 3.175 millimeter end mill, but we can actually expand this menu down. And now we have expanded this menu down, we have all the same settings that we previously did, but when we adjust them, it will just adjust them for this particular job. So as an example, if I take this, let's say up to 0.8 millimeters and go back into the menu where we just selected the bit, if I come back down to that same bit that we selected, we will see that its core values have remained at 0.4 millimeters. However, in the settings specifically for the job, it is 0.8 millimeters. So what I would say is most of the time you're going to want to edit the feeds and speeds within this menu here. Only ever edit them in the tool database if you know that is definitely going to be the speed that you will always use it. I'm going to take this back down to 0.5 where it was originally, and I'll also quickly explain the difference between step down and step over in case you're not familiar with it. Now, step down is about the vertical movement of the spindle itself. So no matter what we set that to, it's the maximum it will cut into the material at any one time. So if, for example, we set this to 1 millimeter deep, it means every time it cuts into the material, it will go into 1 millimeter, complete what it needs to do. Then the next pass, it will come down another millimeter and so on until it goes through the material and gets to the desired depth. Now the key thing to remember here is this is really dependent on the power of your machine. If you have a smaller machine like a 3018, you're going to be doing shallower passes, things like 0.5 millimeters, 0.6 millimeters, obviously depending on how hard the material is. If you have a bigger machine, you may be doing this at 1 millimeter, 2 millimeter steps, or even more. But always remember, take it slow and steady. If you are unsure, go for a shallower pass and you can always build up with more confidence and then do deeper steps later on. On the opposite side, we have the step over. Now this is about the horizontal movement of your spindle as opposed to the vertical movement of it. So if you imagine we are taking a top layer off this material, we're looking down on the material at this point. The step over is essentially once it's completed one pass and it goes to move over to the next bit, is the maximum amount it will overlap of that router bit. Now this can either be set in a percentage term of the bit that you are using or a set measurement such as millimeters. So for example, if we were using a 5mm bit and we set this as a 20% overlap, it would move across 1mm each time. And as I say, you can define it as a percentage or you can define it as a set measurement. But the higher the value, the more aggressive it is going to be. And again, a bit like we just said for the step down, the more powerful your machine is, the higher rate you can do with a step over. Now, usually you will never take this higher than around 40%. If you're doing like a really fast roughing pass, you may have it at 40%, but the finer you take it, the better detail you're going to get, or the better finish you're also going to get on the material. So just to recap, step down is about vertical movement into the material, step over is about horizontal going across the material. And if you are new to this, I will quickly explain the difference between a feed rate and a plunge rate. The feed rate is how fast it is going to feed your bit through the material, essentially front to back, left to right on a horizontal plane. The plunge rate is how deep it is going to initially punch your bit into the material. So as it lowers the spindle down, essentially, that is your plunge rate. So feed rate is horizontal, plunge rate is vertical. You will always want your plunge rate to be a slower rate than your feed. I'm happy with a spindle speed of 1200, and I'm just going to leave tool number as number 1. We scroll a little bit further down. We have the cutting direction. Now essentially this is about the direction the bit will cut through the material. I'm going to leave it on climb for now. If you want to learn more about this, just quickly Google the difference between climb and conventional cutting and you'll get some great illustrations explaining the differences between them. Next we have lead in and lead out moves. Now if you're doing something like this, a profile cut around the outside, what you can essentially tell Carveco to do is make the bit start outside of your line and bring it in at a nice gentle angle before it starts cutting on the actual line that you've drawn. And ultimately this just means you'll have less tool marks on the finished piece. Ramping is also another method that minimizes tool marks in your material, but it can also extend the life of your bits, and I'll give you a very quick demonstration of this shortly. If we expand the menu out, we will see we've got a few choices: spiral, zigzag, smooth, different angles, different lengths to choose from. And as I say, let's go through this in a very quick demonstration to try and explain the differences of this. So we have our spindle, the bit and the material. Now usually your machine would just come straight down and start to go through the material, but this lateral movement then puts a lot of force on the spindle and also on the bit itself and can start to dull the sharp edges. Now what ramping is about is bringing it down at a consistent ramp to enter the material at a softer angle. This can be done in several ways. It can be done over a distance, so perhaps 100mm, and it will slowly come down over that distance till it goes into the material. It can be done at a certain angle. For example, you can define it at something like a 45-degree angle to come in as you like. It can be done over one consistent pass, or it can be done either by zigzagging its way down into the material or even spiraling, which is a similar thing. You can mix both of these. For example, you can say you may want it to come in at a 45-degree angle over a 20mm distance, and that is what it will calculate into it. Ultimately, as I say, it is about bringing the bit and the spindle into the material at a gentler rate, saving your bits and making those sharp edges last even longer. So for the ramping on this job, I'm going to put it to smooth and I'm going to have it at a 45-degree angle, and I'm happy with that. Next we have bridges. Bridges is about securing your material when you are cutting all of the way through it. Now if you're using something like a blue tape and CA glue method, it may hold it down, but adding bridges is just an extra way to guarantee the middle piece when you're cutting through something doesn't bounce out of position, and we'll use them now. So we'll click add bridges and it will give us an extra menu, and you have a couple of different choices. I should say these are also known as tabs in some other software, and they all essentially work the same. To say, it's about keeping the inner piece connected to the outer piece so that it doesn't bounce around. Now for the length, I'm going to set these at 8mm. For the thickness, I think I'm going to put them at 3mm. And we have a choice of 3D bridges or 2D bridges. Now if we look at these illustrations on the left here, the easiest way to explain them is the one that we see at the top is more of a traditional bridge, a 2D bridge, and it can leave tool marks every time it stops to raise the bit up to go over it. With a 3D bridge, it is more of a gentle in and out, and therefore minimises the amount of tool marks you may get. So I'm going to leave this on as 3D bridges. So with my settings correct, I have a choice of whether I want a constant number, adaptive spacing, or constant spacing. And this is just really about how you want the tabs to run around the line. Constant number will give you the exact amount of bridges no matter how big or small the job is that you're doing. Adaptive spacing will space them out accordingly to the size and shape, and constant spacing will space them out as it says at a constant rate all around your job. I think for the purpose of this I'm going to leave it on constant number, and I'm going to leave it at 10. So what this will do is add 10 little tabs all around this line for when we machine it out. And if we click add, we'll now see all these extra little symbols appear on the design. And what we can see is there are a couple of them appearing a bit too close together. So I'm going to click remove all. I'm going to drop the number down to 8 and click add again. There we are, they're a bit better spaced now, and even though the menu is here, there will also be some on the line underneath this menu. You can also use the edit bridges feature. Let's say if you have two a little bit close together, you want to space them out, or they're in what may be an awkward part like a corner, you can click edit bridges, and then you can go in and move these about or adjust them as you need to. I'm happy with the placement of these, so I'm going to leave them as they are for now. And finally, under options, we have two very important sets of settings. We're going to expand the first one out and scroll down a little bit further, and I'll explain what these two sets of numbers are. So your safe Z height is essentially how high you want the bit to be lifted above the material every time your machine is moving about. Now the larger you make this number, it will extend the length of your job, not by much but a little bit. But equally, the lower you make the number, the more risky it is. For example, if you are using clamps to hold down your material and your clamps are 5mm thick, then the absolute minimum number you would want this to be is 6mm to guarantee that it cleared those clamps. And that's essentially the easiest way to think about it, whereas the absolute minimum height you want your bit to raise above to make sure that it doesn't hit anything. I usually leave it at 8 or sometimes go up to 10 if I'm using particularly awkward clamps, but for now we'll leave this at 8mm. Now on the opposite side we have the home position, and this is all about where the job starts and ends. The coordinates we have at the moment is 0, 0 for the X and Y and 8mm high. So when we go to start this job, raise the bit to 8mm above the material and then start the job. And equally, when the job finishes, it will send it back to that exact same place. So this is basically your start and finish line for the job. And finally, we have the option to define our material. Now you may have noticed, even though we set the size of the material earlier, we never set the depth of it. And this is where we do it. So we're going to click into this menu and we get this pop-up, and from here we can set the thickness of our material. Now I said earlier on it is 18mm pine that we'll be machining out. So we'll put that in, and obviously it sets the thickness, and then we get the choice of basically whether we want to start machining from the top of the material or from the bed. And as I also said earlier, 99% of the time, especially for new people, you'll always start machining from the top of the material. So we'll leave all these settings as they are and click OK. And finally, we'll give the toolpath a name. Now it may sound obvious, but give them logical names that you will remember. And with that done, we can now click calculate now. And we have just created our very first toolpath. Now you'll see an extra red line has appeared, and this is essentially the toolpath that we have created. Now one thing I have realized is this is cutting to the outside of the path, as we can see illustrated by the offset between the red and the pink line, and also these curves here sitting away from the pink line. So I'm just going to quickly come back up to the top. I'm going to change this along, and then I'm going to come back down, just make sure everything is still okay. But at the moment you can still see the existing toolpath is in place. So if we click calculate now, it has redone that toolpath to on top of the line that I wanted it to sit on. If we close this menu down for a moment, and what we can do with the light bulbs up here on the right hand side is turn the toolpaths off, turn them on, or we can turn the vectors off as well and turn those back on. Obviously you can turn everything off altogether or put them back on and have everything back on screen. Now, if for any reason you think that you've done something wrong in that toolpath, and let's say you may want to adjust the speed of it, the easiest way to find it is to expand the toolpaths menu, and there is the toolpath that we just created. If you double click onto this, it will bring that menu up that we just had, and it will also select the relevant parts on the drawing itself. So you can come back in, for example, let's say we just want to slow this down slightly, we'll take the feed rate down to 700, and then you can click calculate now and it will redo that toolpath. So now we have created a toolpath. You will see this icon up here has now come to life, and this is the simulation toolbar. And we can also see that it is available over here in the right hand side, and if we right click on the toolpath, it will also give us the same options. Now what I'm going to do is simulate this toolpath, and we can take a look at what it will actually do within the material. Now that generated very quick. The simpler the toolpath, the faster it will be. The more complex the toolpath, the longer it will obviously take. Now what we can see going on here is a cut all the way through the material, and these little dimples are the bridges that we created. Let's zoom in and we can start to rotate this around. Remember, hold down the scroll wheel on your mouse and you can move things about. So what we can now clearly see, it is cutting all the way through the material and it is leaving these little bridges in place, which is exactly what we expect it to do, because it connects the inner piece to the outer piece and makes sure it doesn't bounce out. So let's go back to the drawing, close this menu down, and the next thing that we want to do is pocket out the word James. So I'm going to select that vector first, then head over to the toolpaths menu, and we're going to come down to the area clearance tool. And similar to earlier, if we had multiple layers going on, we would have different ways to select objects, but for now we're going to stick with the selected vectors. And again, like earlier, the start depth will be 0, the top of the material. For the finish depth, I'm going to make this 3 millimeters. I'm going to leave both allowance and final tool allowance at 0. I don't want any type of adjustment on them. And again, tolerance at the default of 0.025. Next up, we have the tool list menu. Now there's something like an area clearance job. You can add multiple tools to it to potentially speed it up or alternatively get you sharper results. For the purpose of today, we're going to keep it simple and we're just going to use the same bit that we used earlier to do all the clearance as well. So we're going to click add. And in the tool database, it will remember the last menu you had open. So we can see the Saint Smart menu is already expanded. And again, we're going to select the 3.175 end mill. And we'll leave all the default settings as they are. Click select. And as I say, it's just loaded in the same default settings from the database. But let's make this a fraction deeper. We're going to take this up to 0.5 millimeters deep and leave all the feeds and speeds exactly as they are. Now a bit further down, we have the tool clearance strategy. Now the illustrations are fairly straightforward here. A raster will essentially clear it going left to right all through the job and work its way through each shape. The offset tool gives you a few more choices. You have climb and conventional mill, as we mentioned earlier. We'll leave it as climb as default. And you also have inside or outside. Now we can see from the illustration, it will basically start from the middle and work its way out in a circular motion to clear the path that it is doing. Alternatively, you could select outside. It would then follow the outside of the shape and work its way all the way back into the middle. For today, I'm going to leave this on raster. One thing I will point out is you will usually get a better finish with raster if you are going in the grain of the wood. So if the grain of your wood goes left to right, then go with raster and leave it at 0. But let's say you're machining something and the grain is running top to bottom, you can rotate this around to 90 degrees and it will then do that raster but rotate it and essentially go front to back instead. I'm going to leave it as 0 because left to right is fine for this job. Now I could add ramping moves in like I did earlier, but I'm just going to leave them turned off for the purpose of this video. And finally, we're back down to the options menu where we can choose between the safe height and the material thickness. Now, once you've already set up one toolpath, it will carry all of these options over from the previous one that you set up. So we can see that the safe Z height is the same and the home position is also the same. And also the material thickness and setup again is all the same. And this is correct. They should all be the same across each job. And last, we just want to give it a name. So we'll call this one Pocket and then we'll click Create Now. And it's generated our toolpath. We can see we've got that raster effect going from left to right. Just to illustrate that a little bit more, I'm going to rotate this now to, let's say, 90 degrees. And I'm going to recalculate just to show you that. And you'll see it's changed the direction of travel for the toolpath. And I'll also show you the offset as well. If I click that and generate a new toolpath, you can see that it works around the shape in a different way. Instead of going left to right or top to bottom, it focuses more on the actual shape itself than the direction of travel. But I will just revert it back to the raster cut, set the angle back to 0 and regenerate that path. So if we click back over to the 3D view now, and zoom out slightly, what we can see is in the simulation we've got the previous cut that we did earlier, and we can now see the toolpath for the job that we have just generated. But we want this to simulate all together. So what we're going to do is right click on the simulation, reset it, and then we're going to click simulate all toolpaths. And again, if we rotate this round a little bit, clicking at the scroll wheel on the mouse, we can start to see that has machined it out. And we can also see this in relation to the toolpath itself by coming back over to the light bulbs on the right hand side and toggling the 3D visibility ones on and off. And this essentially shows us all the work the machine will be doing to achieve the outcome that we want. Now obviously there are a lot of red lines here. I am basing this on a small machine doing very shallow passes at a slower speed. If you can do deeper passes, you'll obviously have a lot less red lines in order to achieve the same outcome. Now another quick tip, by default the simulation will always generate on this grey background, but we can change the type of material. If we come up to the simulation and click on it, we'll see down the bottom we have material, and we can change this to a variety of different things. The list is quite large, but as I said, I'm doing this on pine today, so I'm going to select pine, then click apply. I'll then turn the toolpaths off, and it just gives us a better indication of how this may actually come out in the pine. So one quick thing I should have pointed out, obviously pine is quite a white wood, so when you select it, it does give you these white edges. This is not a simulation error. If we switch to something that is different, such as medium oak, and click apply, it will change the colour of those edges as well. So definitely do go through the selection of different types of materials, woods, metals, plastics, acrylics. You've got a wide variety in here, and you get lots of different effects depending on the material that you do select. So we've drawn everything out, we've generated the toolpaths and also done the simulation. A next useful thing to know is how long we expect this to take in order to machine out. Now I'm just going to turn the toolpaths back on for now, and I'll explain why shortly. I'm going to come up to toolpaths. I'm then going to come down to the notepad symbol, and this gives us the toolpath summary. Now there's a bit of useful information here. It confirms the width and height of the material, also the thickness, but crucially it tells us the machine time. Now it is estimating this job at 50 minutes. The way it does this is it calculates all the distance it needs to travel with the red lines. It also factors in your rapid rate. Now on the simulation behind us we can see the blue lines. The blue lines are when it's travelling between different cuts, and this travels at what is known as your rapid rate. These are your GRBL 110 and 111 settings. Now for most desktop machines they will be set at 2000, but they may be higher. Check your settings and input that value into here. And there is also this timescale factor. Now the first job you do, leave it at 1. And the reason this is important is giving a rough estimation. But after your first job, time exactly how long it takes, or look at the values in your controller, as I say, to track how long the job takes. And we can then get a better estimation for future jobs of how long they are going to actually take to machine. And I'll show you how to calculate this now. If I move this over and drag in the calculator. So this is estimating at 50 minutes, but let's say for example it actually takes 60 minutes. So we put 60 minutes into the calculator and we divide that by the estimation that it should have been. So divide this by 50 and it gives us a scale factor of 1.2. So if we go back to the time scale factor now and put in 1.2, click calculate, and it regenerates the machine time to be more accurate. Now track your first couple of jobs and take the average and get the best measurement you can. The more accurate you make this, obviously the more accurate your machine estimation time is going to be. It will never be 100% perfect, but we can get it as close as possible. So just to reconfirm, take the time it actually took, divide that by the time it was estimated to take, and that will give you the time scale factor. Now in this summary there is also extra useful information. This gives you the overall machine time, but when you're doing more than one toolpath, it breaks each toolpath down and gives you a reminder of the settings of that toolpath, such as the speed and feed rates. It also gives you an indication of the time for each particular toolpath. So at the moment this is saying the first toolpath will take 27 minutes to complete and the second toolpath will take 32 minutes. And if you're a real geek and like your extra information, you can actually see how far the machine travels to complete each job. So let's close this down. So we have pretty much done everything. The final step really is to get these toolpaths out of Carveco into files that we can use in our control software. So in order to do this, we're going to come to the little save symbol. If you can't see this, again, just as a reminder, click on the toolpaths menu and then click on the save icon. Now this is the hurdle that a lot of people actually fall on by selecting the wrong settings at this stage, and ultimately the job doesn't come out the way they expect. To begin with, I'm just going to transfer all of these toolpaths over to the left hand side. You don't really need to do this if you only have two toolpaths that are the same bits, but I just want to show you how it works. Now between these two boxes you can interchange the toolpaths that you have generated versus the toolpaths you want to save. Now the reason they may be different is if you're doing toolpaths with different bits, then you'll want to save them out separately. For the purpose of today though, both of our tool bits are the same, so we can transfer these over to the toolpaths and export them as one. And if we transfer them over in the order that they were, and what we can see is it's going to do the outside profile first. Now the reason it's doing this is because that is the first toolpath that I generated. Now a general rule of thumb is your outside profile cut is usually the very last one that you do. So what we can actually do is select the pocket cut and move this up first. So essentially what it will do is machine the James out. Once that job has finished, it will then move on to the profile cut and do the cutting around the outside. Now down in the left hand corner we have a couple of options, such as to save the toolpaths out as separate files. So even though these are using the same bits, we could ask it to save each one out as a separate file. For today though, we are happy to save them out as one file. The next thing you do is select the area you want to save them to. It may be your hard drive, it may be your desktop, it may be a cloud service or a USB stick, as long as you can access the files. Then give them a file name. This is obviously remembering the last job that I did, so I'll just call this James Sign. Next is probably the most crucial step to guarantee you get the best results. Open up this menu and you will see what are called post processors. This is all the information that it does to your toolpaths to make them compatible for the machine you are about to use. Now there are an awful lot of variations in here, and this is why people get confused. Now there are post processors in here that do relate to some machines. For example, there is a SaintSmart one down here with different variations, and also lots of other machines. But if your machine is Gerbil based, which it probably is watching my videos, the best option to select is one of these two, GRBL inch or GRBL millimeters, depending on what setup you are using. I work in millimeters, so I'm going to be selecting the millimeters option. Now just to really drill this home, these are the ones that you want. There is also a very similar option that people often select, which is the G code option up here. It needs to be the GRBL millimeter or inch. So we'll select that one and then we'll click save. Now it doesn't actually give you a confirmation message to say this has been successful. The way I usually test is click the save button again and it will give you a warning message about overwriting your file, and just click yes and it just guarantees that it has actually saved that file. And that is everything. We have created a job. We have generated toolpaths for it. We have exported the files out and we can now go and open them in our favorite control software such as UGS and get the job started. And if you have never machined anything before, then check out the link in the corner. This video will take you through using the files that we just exported, loading them into your G-code sender, making sure your machine is good to go, and ultimately getting your job finished.
So we've created our very first model, we have created our very first set of toolpaths, and ultimately exported our very first project from Carveco Maker and picked up some useful tips along the way. Now that is everything for today's episode. Do make sure that you are subscribed and also check out the playlist in the corner to keep an eye on all future episodes. We will be progressing forward from this point and doing some more advanced things within Carveco Maker. Thank you everyone for watching. Obviously, any feedback, let me know in the comments section down below. Final thanks as always goes to my patrons, and I will see you all on the next episode.